It's gray. I don't like it because I'm a California girl. I like my sunshine, okay? But in California, when I'm living in California, hello, Dylan. Hello, it's all. When I'm living in California, bring on the rain, right? I love a good rainy day in California because we only get them once in a while, right? So I can appreciate it. But if I'm living somewhere where it rains all the time, I do not like it. So I'm on the fence. You know the best thing to do in the rain? Does anybody? What's the best thing to do in the rain? What do you think I'm going to say? Tony likes the fire with the rain. Sleeping in is not what I do in the rain. You know what I do in the rain? I love to do in the rain. When it rains in California, I put on all, no, not dance. No, you don't want to see that. My children all do that, not mom. We put on all of our rain gear and our rain boots. Can anyone guess where we like to go? Where do we go? Where do the Ballards like to go in the rain? We don't jump in puddles. No, I might have the kids do that this afternoon. We'll see if there's any puddles left. Because we still have all the snow gear here. Nope, not the park. But it is a park, but not the park. Hello, Emily. So you guys don't know me well enough. Our obsession would be that we go to Disneyland because it's empty, because nobody wants to be at Disneyland in the rain, but it's amazing in the rain. But we can't do that right now because Disneyland's closed. So Disneyland rainy days are the best. All right, everybody, we are here. We are doing expansions and contractions today. This will take us maybe 15 minutes to do, maybe. Hopefully you did do this part of the lesson up here you were supposed to. Actually, let me flip to here, and I'm going to go back and we're going to review this really quick. Okay, oh, no, not there. I got to go here, and we're going to look at the other class period where I had it written. Okay, so let's talk about this really quick. Properties of logarithms. You were supposed to watch this on video, so let's see what you remember, okay? Because this was part of Monday or yesterday, right? You were supposed to watch it yesterday. So when we are multiplying inside of a log, what does multiplication turn into? Can you answer that for me in the chat? What does multiplication turn into? All right. Either we're reading very swiftly or we did the lesson. That's good. But I've only got about a third of you. So I need the other third to come and help me out. Or the other 2/3, not the other third. Boy, Mrs. Ballard, I can't add fractions today. You got to help me out. Hello, Brian. Welcome to class. All right. So what does, I'm going to give you another chance. When we have division, what does division turn into? Everybody put it in the chat. Remember, we're getting points for, and part of our grade is participating in the chat. Because I got to know that what you're thinking, and I need to be able to gauge your understanding. All right, subtraction, good. And I like it because it's horizontal. They're both horizontal, little tiny horizontal lines. And then the other thing that we're going to use today is if we have an exponent, we are allowed to move it to the front. And remember, all of these things work backwards as well. If my number is in front, I'm allowed to move it up as an exponent. Okay, I think we got like 7 examples to do. Let's do it. Oh, I'm in the wrong. Got to go back over to this one. Okay, so we have log base 4 of 5x cubed y. All right, we have multiplication, and you just told me that when we have multiplication, we turn those into additions, and we're going to split every little piece apart. Okay, so we're going to write it as log base 4 of 5 plus log base 4 of x cubed plus log base 4 of y. Okay. We are now there's one other thing I have to do, because if I'm doing an expansion, I cannot leave exponents. All right, so I'm going to have to take this exponent, and Mrs. Ballard says, hey, throw it in the front. Right, I get to put it in the front. So I would do log base 4 of 5 plus 3 log base 4 of x plus log base 4 of y. That is a fully expanded logarithm. And again, we're taking a lot of baby steps this week. Next week, we're going to put this all together. Okay, and we will be wrapping logs at the next week. So like a week from Monday is probably the test. Okay, so that's where I'm aiming for a test. And then, hello, Jose, welcome to class. Then we get to start trig, okay, because that's exciting. We want to get to that trig. All right, I'm going to skip 15 for just a minute. Let's do 16 and 17, then we're going to come back to 15, okay? So on 16, I want to have exponents. I don't want to have radicals. So I'm going to convert to a fractional exponent. So this is something we did in the last unit. What would my fractional exponent be on the A? So what would I write up on the A? Can you tell me in the chat, please? All right, 1/3, perfect. All right, now help me out. If I have an exponent, where am I supposed to put that exponent? So where does the exponent go when I'm expanding? I'm waiting, I want to hear from everybody. Where does the exponent go? All right, good. We're going to throw it in front. We're going to kick it to the front. So 1/3 log base 2 of A. That's it. That's expanded. Do you see how quick these are? So don't panic when you see that there's like 27 problems on the homework, okay? They're fast. And there's a lot of little tiny things. So I wanted to make sure you had 3 or 4 practices of each one, okay? All right. We have one with some division in it here. So what does division turn into? Can you put that in the chat for me again? What does division turn into? Oh, I'm already giving it away. That's not good. What does division turn into? Good. We're turning it into subtraction. So I got minus natural log of 7. Now you'll notice I put parentheses there with it blank because I want to talk about this. I want to convert this to a fractional exponent. So remember, the root is going to become a 1/2 power. Okay. And again, just like you told me in the last problem, we're supposed to take that 1/2 and it gets tossed in front. So 1/2 natural log of 3x minus 5 minus natural log of 7. The parentheses are important. Make sure you have them there. Okay. All right.
Miss Ballard?
Yep, go ahead, Amy.
Can you re-explain why you add the exponent in there, the 1/2 exponent?
Why I made it 1/2?
Yeah.
Okay. Because what I did was I noticed I had the square root of 3x minus 5, right? I know the square root converts to a fractional exponent of 1/2. So I converted it because I don't want any radicals over the top of these things because radicals are really just an exponent, right? So I want to get rid of my exponent when I'm expanding. Okay. Eventually what we do with these is eventually we're going to go to solving, and this manipulation is going to help us solve. Okay. Do you have more questions, Amy, or are we good?
Like I was thinking, like, why don't you put 2 as the exponent though?
Why don't I put 2 as the exponent?
Yeah.
Because inside here I already have an exponent of 1, and remember the roots are at the bottom of the tree, right? So the root goes in the bottom. Okay. Got it?
Okay, okay. Yeah.
Okay.
Got it.
Okay. We're going to go back up to 15 now. All right, everybody ready for 15? Here's what I want you to do. I want you to take 1 minute, and I'm going to be quiet, and you're not going to type anything in the chat. 1 minute. I want you to try 15 on your paper, but we're going to adjust. Let's get rid of the base 2. Let's just make it log. Okay, so get rid of the base 2, just log. Figure out what that one is. Okay. I won't talk till 2:03 and 30 seconds. Okay. Everybody try it. Okay, here's what I want you to do now. I want you to put your final answer, not any intermediate answers, but the final answer in the chat. I want to check and see where we're at on expansion. So final answer in the chat for me, everybody, please. It always makes me nervous when it takes a while, but I know you have a lot to type this time. Let's see how fancy we get with it. So final answer, put it in the chat. Ooh, we got one. Let's see if we have any agreement on that. Okay, we got two. There we go. Now we're cooking. I'm going to wait another about 30 seconds here. I want to make sure everybody has a chance. Alondra, I'm going to catch that question here, okay? Because I want to make sure we bring up that point of confusion. Okay, so I'm going to go through the expansion because I didn't hear from everybody, so I'm assuming people who didn't put it in the chat don't have any understanding of what we're doing. Okay, and then I'm going to answer the question about log, natural log. Okay, so multiplication, remember, turns into addition. So I'm going to expand this by going log of 3 plus log of a to the 5th plus log of b cubed. And then I'm supposed to expand this, I'm supposed to take my exponents and move them in front. So I would have log of 3 plus 5 log of a plus 3 log of b. Okay, now I saw one person put a natural log on it, and I had a question. Alondra asked, instead of log, can you use natural log b? The answer is no. Okay, so when it's in this format here that we're looking at, you cannot switch a log to a common log. Okay, when we are doing change of base, which is not something we do very often, but it does occur, then you can use either log or natural log. So remember the log of the number over the log of the base. That's what we did. That was the video part of the notes, right? That is equivalent because it's a ratio. The log of the number over the natural log of the base. Okay, so when we're expanding an expression, don't convert it to natural logs. Okay, or if it's in natural log, don't convert it to common logs or regular logs. I did this because I wanted you to type the answer in, so I took that off and changed the problem. Okay, really I should have left it base 2, but I wanted to make it easier for you to type. Okay, all right, we're going to go the other direction now. We're going to condense. All right, we're ready to condense. So the condense means that we're going to go backwards now. Okay, so think about the order we did things. First, we would do add and subtract. The multiply divide turns into add and subtract. Then we would take our exponents and move them in front. So we're going to go opposite. We're going to take our exponents and move them back. And then we're going to turn add and subtract back into multiply and divide, make it smaller. Okay, because we're going to condense. We're going to jam it together. When we condense, we got to get it down to where we only have one log or natural log out front. Okay, so first thing I'm going to do is exponents. So I notice I've got a 1/2. I'm going to raise that exponent. So log base 10 to the 1/2 power. I've got a 3. I'm going to move that up as an exponent. Plus log base 10 of x plus 1 cubed. All right, help me out. What does addition turn into? Can you tell me in the chat? What do I have to convert addition back into? And I want to hear from everybody. I want to make sure you're all still there paying attention. Not just these 7 people that tried the last problem. All right, it converts back into multiplication. Good. So I'm going to have log base 10 of x to the 1/2 times x plus 1 cubed. Okay, now it's a WebAssign assignment today. All right, so if you haven't logged into WebAssign yet, you need to figure that out. Okay, because it's all embedded in there. And we had an account first semester. Remember, we had to reuse our account and add a new class code second semester. So this thing here, I don't know how they're having you type your answer, what they're going to count as equivalent answers in there, because I didn't look that closely. So this could be converted back into a radical. So I could rewrite that as the square root of x times x plus 1 cubed. We could put them in opposite order. Okay, so just know that that may happen. On my test, both of those are correct answers. Okay? All right. Let's think about what we're going to do first. So look at example 19. What should we do first? Yes, we have a new code for this semester. It's in under week 7. Okay. All right, so everybody's telling me in 19, what are we going to do first? What do I have to move first? Okay. So a few people have told me we've got to move that 2, that's the coefficient. We're going to make it an exponent. So the natural log of x plus 2 squared minus the natural log of x. And again, whatever I do with a log, I can do with a natural log. Okay, tell me in the chat, what does subtraction turn into now? Because I'm condensing this back down, so I just have one single natural log in front. So what does subtraction turn back into? I want to see everybody participating. All right, so we're going to turn it back into division. So I write the natural log one time, and then I write it as a fraction. X squared, x plus 2 squared over x. Done. Now I'm condensed back down. Okay. 20 is a little bit tricky. Okay, and you're going to run into ones that we didn't exactly see in the notes. You got to use the rules that we've learned, okay, and do the best you can. Okay. I am going to do what's in the brackets first, and then we'll deal with moving the exponent. If the brackets weren't there, then I would move the exponent first. Okay. So what does addition turn into? Can you tell me that one more time in the chat? What does addition turn into? All right, multiplication. So we've got log base 2 of x times x minus 4. Now, typically, I'm not a proponent of, hey, let's just distribute for fun, okay? In this case, because I have to move that 1/3 up, I am going to distribute my x. So I'm going to go 1/3 log base 2 of x squared minus 4x. Okay, let's see if we can, because I didn't get everybody to answer last time, okay? What is the next thing that I need to do to finish this off? To tell me what the next step is, please, in the chat. This will be like the last thing we get to put in the chat. What specifically, where's that 1/3 going to go? I'm seeing move 1/3. Can we be more specific? What am I going to turn it into? What do we call it? It's got that funny word. What do we call it? All right, there we go. Good. We're going to move the 1/3. We're going to move it up and make it an exponent. Perfect. You guys are doing good. All right, so we've got log. Oh, what happened there? My goodness gracious. Okay. Log base 2 of x squared minus 4x to the 1/3 power. Again, 100% perfectly correct answer. However, whenever I have a fractional exponent, there is always the possibility that my answer gets put back as a radical. So it would be the cubed root of x squared minus 4x. Again, 200% correct answers. Okay. I will take both of those on the test. You might have to manipulate it a little bit when you are in WebAssign. Okay? Are there any questions, comments, concerns? Looks like it got a little bit cloudier. I'm kind of peeking out the one window. I can kind of see out of it. It got sunny again, and then it got cloudier again. I think we're supposed to get another wave. How was my day? It's been okay. It's been rather refreshing in the last like 15 minutes, 20 minutes because I finished grades, right? I've been up since 4 working on that and getting ready for the day. And then I got to sit through an hour of professional development this morning. So that was exciting. Let's do some, let's do a joke of the day. How many days till Pi Day? Does anybody know? How many days till Pi Day? I haven't decided when exactly we're going to celebrate, but how many days till Pi Day? Remember, Pi Day is on the 14th. Yeah, we can't, I don't know how we're going to eat virtual pie. I could sit here and eat pie in front of everybody. That would be exciting, wouldn't it? You'd all be mad at me if I did that. I did promise, when we go back to my classroom, we're eating pie. You just have to make sure you show up and you're in my class, right? Yeah, Andrea doesn't like, or Ariana doesn't like these that like me eating pie in front of you all. Okay, so we won't do that. Okay. Okay. Here he is. But he's prepping us for Pi Day by doing pie jokes. At $1 shipping. I can't afford that. I have to feed 4 children here at home. So I wish it would cost me like more than pie would cost me to ship it to all of you, to each one, to ship it to all of you. All right, here he is.
Hello. Why isn't Pi on Twitter? Because even 280 characters isn't enough to express itself. I'll be here all week, because I live here.
All right, and there it is. Okay, what you have left to do today, okay? If you did not watch the first part of the lesson, you should go do that so the homework makes sense, right? So make sure you have that part done, okay? And then what you have left to do today is working on homework number 36, which is a WebAssign assignment. If you have yet to log into WebAssign for semester 2, look at where I'm going. Under View More, right in here, WebAssign login info. Okay, you click on that. You click the link to WebAssign. And you already probably have a Cengage account. It might ask you to log into it. Log into it. Okay, hopefully your password got saved because we did this the very beginning of the year. We got a WebAssign account. Then you click Enter Class Key, and you only need to do this Enter Class Key thing once. The class key is right here under it's the talk with CA. That whole thing is what you have to put in. Okay, so make sure you do that. Sometimes WebAssign is finicky, and you have to do it a couple of times to get it to register. And sometimes you have to put it in and then walk away for a little while and come back, magically complain to Mrs. Ballard, and then it works. I don't know what it is, but that's what happens, okay? So please do not wait on WebAssign stuff. Get it done, because it takes a little bit to access the product, okay? Well, then make up a new password, Amy. Use the 5. All right, that's all I have for you guys today. Have a great afternoon. I will be sitting here for a few more minutes. If you've got questions or concerns, please get your work done. Bye, Matt. Have a good day. Bye, Amy. Have a good day.